So quantum technologies are pretty broad. There's sort of a few big categories. There's quantum computing, there's quantum sensing, and there's quantum networking, each of which has their own stack inside of it. So I think one of the stories about the last few years that's shifted is maybe 5 or 6 years ago, what came onto the scene was the idea that you could make computers using quantum mechanics, and these would be faster in a bunch of different ways. There's of course a tech stack inside of that, everything from fabrication up to the cloud software that controls them. But what's become more apparent in the last few years is that these is not about one product, a quantum computer, or one particular technology. It's actually about many technologies that work together using quantum mechanics in new and novel ways. So sensors can be technologies that help improve how computers work. Networks can be used to connect quantum computers. There's algorithms that come from these that you actually can run on normal processors in hybrid ways. You can use quantum computers to design new materials. The relationships between all these things form an industry. So the tech stack is not so much a stack of what goes into a quantum computer. The question you should be asking is what's the tech stack for an entire industry based on quantum mechanics that come up with many different products and technologies that affect many sectors.
3 large classes of problems or challenges that a quantum computer can tackle is first acceleration of machine learning, second is large optimization problems, and the third one would be simulation. And so the industries that would be interested for that, for example, in simulation would be chemical industry or drug discovery, big pharma for drug discovery. For optimization, anywhere between finance, large industries, networks can have large optimization problems, and machine learning.
Some of the original investments in quantum technologies were very full stack. You had to build everything in-house. And now that the industry has advanced, there's 40 billion of public funding helping fund basic research and technology transfer. You can build businesses that are more modular and fit and do some of it more outsourced. So that opens up some new opportunities. Another trend is that quantum sensing technologies, which have been at higher technology readiness levels for a while, have sometimes been limited by the markets being smaller, but some of those markets are getting bigger. And so that's something that we see as a trend too.
Quantum communication, as Will mentioned at the beginning, has been slow to materialize, but we are now really a strong push. People are experimenting, looking at how to build quantum networks, and there is a very nice project of a QKD network that's going to be launched in Singapore and with potential future links with the satellite QKD. That's a good example. We are also seeing strong push in, for example, quantum materials. So people using quantum simulation to design new forms of materials with special properties, conducting electricity better or storing electricity. One big trend is that we are starting to see which could be the problems that will be better tackled by a quantum computer than by a classical computer. And used to be, we would not know when this would come. Now it's pretty sure that this is happening in the next 12 to 18 months. So quantum computers will prove to be useful for certain usage in the next 12 to 18 months.